All right. Hello to everybody and welcome to this week's edition of KETIV Virtual Academy. Today, we're going to cover some of the exciting new features available in Fusion 360, and who better to show us around than Autodesk themselves. We have Spencer Hardcastle here. He's the manager of customer advocacy in the Fusion 360 business at Autodesk. Joining him from his team will be Kieran, Jacob, and Kyle to walk you through what's new in Fusion 360. And we also have Marco Trinidad, who's an application engineer here at KETIV to help support any questions that come up throughout the call. Just a couple pieces of housekeeping. As usual, please feel free to send questions via the Q&A. I know there's a chat and a Q&A, but send them through the Q&A. Marco will try to address them, or if we want to do some at the end, we can do that. And also, all of these sessions are recorded, so please feel free to check them out on ketiv.com, on our YouTube channel, and distribute them as needed. So without further ado, I'll pass things over to Spencer to introduce himself and his team and kick us off.
Thank you so much. Welcome, everybody. It's an absolute pleasure to join the KETIV team here today on this webinar. We're going to cover what's new in Fusion 360. Super excited to dive in. I'm joined today by the real experts. We have Jacob Weinstock here. He's going to take us through everything you need to know about simulation in Fusion 360. We've got Kyle Williams. He's our resident Canadian, and he's going to take us through everything you need to know about the wonderful world of design and all the latest design and documentation updates that we're seeing in the latest release of the product. And then, of course, the maestro himself, Mr. Kieran Gill, who will take us through everything you need to know about manufacturing. Now, as we're going through, if anybody does have any questions, please use the chat, use the Q&A. If you're watching on YouTube, let's comment. Let's see where you're joining from. It's always super exciting when we do these live streams to see where everybody's joining from all over the world. So it'd be super cool to hear where everyone's joining from. But without any further ado, let's just go ahead and look at a little bit of an overview as to the May release and a little bit of a look into some of the key themes. Just wait a few seconds for that screenshot to come up. There we go. So the May release went live 2 or 3 weeks ago now, and what you're going to see over the next sort of 45 minutes to an hour is a real look into some of the new functionality, some of the new capabilities, some of the new workflows, and importantly, a little look into some of the key themes. And that's what we'll start with today. So as we're going through each of the features, each of the workspaces, keep these themes in mind, because you're going to see them crop up time and time again as we dive into the software in detail and show you really how to maximize the use of the product. And we start with the theme of automation. And so when we talk about automation, you can talk about automation in a variety of different ways. And one of those ways is as simple as leveraging something like an API. In the previous release, before May, in the March release, we added and opened up the API for the manufacturing workspace, exposing up 70% of the user interface within that API. So you can really start at creating macros and add-ins to automate some of those workflows. And we're building on that this time while opening up the API for the rendering workspace. So super excited to see how users are going to start to not only automate their rendering applications, but also start to link some of that automation that's been opened up in rendering with some of the other workspaces. Now, another way you can think about automation is on the feature level. And we've added a super cool new capability to the product design extension in the lit feature. Super common feature and design methodology that's used when you're talking about designing parts for plastic injection molding. And Kyle's going to take us through all the details there with a live demonstration in a little bit. And the last piece of automation I just really wanted to highlight was the ability to use conditional expressions and logical operators within that design workspace itself. So we've had the ability to program using parameters for a long time. But it was always that ask. It was a really common request for those that did use parameters to start using expressions, to start using logical operators within that dialogue, to start building a lot more complex scenarios and situations where You change one parameter, and not just the size and shape of the part could change, but the fundamental design principles behind that design could also change. And that's what adding these conditional expressions brings. And so a whole series of automation enhancements there. And like I said, keep your eye out for different pieces of automation all the way through each and every workspace. The second theme I wanted to call out really is focus on the manufacturing workspace. And that's the idea that we continuing to expand the capabilities across the entire manufacturing board, regardless of application. So we've got two brand new 4-axis machining strategies to showcase today. And like I said, Kieran's going to take us through all the details there. I'm super excited to get your feedback on it. We're really proud of them. It really starts to open up Fusion for 4-axis machining. But it doesn't just stop there. We've got turning improvements in this release. We've got nesting enhancements for the 2D applications. Think of lasers, plasmas, water jets, and routers. And then a whole host of additive capabilities brought into this release too. And then the last theme is really looking at user flexibility and allowing the user to use Fusion in the most flexible way possible so that you can really start to dive into how you want to use the product rather than how we want you to use it. And so some of the flexibility additions this time, and the big one is snooze, right? So the ability to say, well, I'm actually at a really business critical point in my journey right now with this part. I know that the software right now is capable of doing what I want it to do. I just want to get it out the door. I don't want to be dealing with an update at this point. And so that's perfect. That's the whole reason why we're introducing the ability to snooze or postpone an update for up to 14 days. Now, that snooze period does depend on your license type, but the maximum duration here is going to be 14 days. And it really does allow users to make that decision, make that data-driven decision on whether you want to consume an update at this point, or whether really you'd prefer to do it in a day, 2 days, 3 days, after the weekend, after you've got that part out the door. And so providing that flexibility on the consumption of an update is super exciting and something we've been working on for a while. A couple of other flexibility items just to bring to everybody's attention before we dive into the nitty-gritty of each and every workspace. The signal integrity extension, an electronics extension that was introduced back 3 or 4 months ago now, to the end of last year, but more than 3 or 4 months ago. Where's the time gone? To the end of last year, in fact. And signal integrity extension allows you to build more complex electronic schematics by opening up the ability to detect and simulate electronic signals to be able to better design first, write first time schematics. And so what we've done in this release is allow users to consume that extension using tokens. So previously you could go monthly, you could go yearly, you could go 3 yearly if you wanted to. But what tokens allows you to do is consume it on the daily, right? So I'll spend some tokens, I'll access it for today because this particular schematic I'm using is really complex, right? You might need it for 2 or 3 days. But then for the most part, you don't really have or work with that level of complexity all the time. And so that's what Fusion's extensions are built on. It's built on that flexible access program, the ability for you to decide when to consume and when to use this more advanced capabilities. And then lastly, actually back in the design workspace, when we're talking about flexibility, we're talking about edit in place. That's the idea, to edit referenced in files right there in the file that you're working in without needing to open up a variety of different components and files to edit them. And so edit in place historically has had a subset of the design capabilities. We haven't exposed everything, but it's been a subset. In this release, we're significantly growing those capabilities by exposing a lot more of the capabilities, allowing the user to really make that decision. Do I want to edit in place? Or do I want to open up that file and really get into the weeds of the design? And so 3 themes: a theme of automation, a theme of being comprehensive, and a final theme of allowing the user to use the product in a flexible way. And as I said, as they go through each and every workspace, keep those themes in mind. If anybody has any questions as we're going through, please use the Q&A. Please use the chat. If you're on YouTube, use the comments. I'll be in there. I'll be after each workspace, we'll be diving into some of those questions. So please keep them coming in. But for now, I'd like to stop my share and hand it over to the one and only Kyle Williams, who's going to take us through the design workspace. Kyle, over to you.
Thank you, Spencer. Hello, everybody. Welcome to the design section of the What's New for the May release. My name is Kyle Williams, as Spencer mentioned, and I'm one of the design experts for the customer advocacy team in Fusion 360 here at Autodesk. Today, I'll be covering a few updates in the May release, specifically conditional parameters and the plastic lip function, which is inside the product design extension. So let me share my screen for everybody here. So jumping into the conditional parameters that have been added, I will start from the beginning in case you haven't used parameters before. So that function's been in Fusion for a while. You can set up variables such as length, width, height, and you can use these in sketches or features such as the extrude. It'll all be inside of a table. It'll have a list of variables where you can adjust them on the fly without needing to edit the sketch or the extrudes. So things like that. So you can edit all of these things within one table. What you could do before this release was mathematical functions. So you could add parameters together, multiply them, stuff like that. And in this release, we've now added the ability with more automation to do conditional logic. So if statements, not statements, or and things of that nature. So I'll do a quick demo to show some of the basics. I'll be using some if statements, some nested if statements, just to show you what's possible, nothing crazy. Obviously, you guys can go wild with it. So open up first table here. And let's just isolate the fan blade because that's what I've set up. Sorry, that's what I've set up my table to have. So you can see here there's a bunch of different user parameters. There's the fan blades, some angle, thickness, depth, all that. So these are all looking at one variable that I've set here, fan choice. So going through the syntax here for what you're going to, the main thing you'll notice updating, although there's all of these are obviously going to update, is the fan choice variable here. If it's 0, so if fan choice is equal to 0, true statement 5 blades. If it's false, it'll be 18. So anything other than 0, it'll return 18. So I change this to 1, and you'll see that it will update to the false there because fan will be 0. It'll show 18 blades. So there you go. It's also updating all of these other statements that are checking for the same thing. So you can see that that's pretty powerful. What I've essentially done here is made 2 different fan blades in one assembly. So it's a simple use case, but it illustrates how powerful it can be for users. So this functionality shows that a customer building something like a cabinet could automatically make changes to width and height and change things like the count of hinges, doorknobs, their location, the amount of shelves, and things like that. So let's switch over to show something else. It has some nested statements and some and ors in there. So this is just a cabinet shelf. You can see here we have a little bit slightly more complex logic here. So the thickness is just if the height is less than 400 and the width is less than 400, then the thickness of these walls here will be 12. Otherwise, it'll be 18. So currently it's 18 because you can see the height and the height and the width do not follow because the height is larger. So if I update this height value to something smaller under that 400 value, I guess we'll change this one as well. So you'll see we get smaller cabinet. This updates 12. The amount of shelves also updates to give you 2 here. It was 4 before. So that's kind of the power that you have with these conditional parameters. And I guess, do we want to take questions on the parameters first and then switch over to the lip, or do you want me to just go through the lip now?
No questions just yet. I think go okay. To lip and then we can circle back.
Cool. All right. So let's jump over to the lip feature. This is part of the May release that is in the product design extension. So let me set that up. I just have a section view here so you can see it a little bit better. So this one, like I said, is in the product design extension, sorry, on the plastics tab here. So right here, you can see there's the lip and groove icon. So for this feature, this function, sorry, you select feature here. I'll select the edge. What it's then asking for is the pull direction, which is the direction the mold comes apart from. I will select the Z-axis plane for my part. You can see there it automatically generated some revolves and some extrudes, some cuts, sorry, revolve cuts and revolve extrude. In this case, right now, it's just doing the lip. You can also just do the groove or both. There's also the ability to flip the direction, which will just change which side is the lip and which side is the groove. And then you click OK, and it will do its thing. And there you can see, pretty simply, we've added the lip and groove. And the reason why this is important is, so with injection molding, obviously you can have shrinkage, defects when things cool. Things can become warped along the seam. And with a zero tolerance face that those were before, that can become quite obvious. So the lip and groove helps to alleviate that issue. So yeah, those are the standout features from the May release. Hope everybody here is excited to try them out, and I will stop my share and then back to you.
Thank you, sir. Amazing to see the progression that's happening in the product design extension. Thanks for going through that. Really quick question for you. All around the product design extension, I guess, is it's a relatively new extension. Lip and groove, what does that complement? What's some of the other capabilities that you can find within there?
So yeah, I mean, there's a lot of capability in there. So I don't want to not give it its credit. But so there's plastic design rule is a big thing. So for that lip and groove, it's using those design rules like the thickness that you've set, the minimum thickness, to design that lip and groove. It can create bosses, which obviously is to attach things with screws. The snap fit feature, so it'll automatically design some things so you can snap plastics together. There's the rest feature, so it'll create a flat surface on some rounded stuff, so you can have a nice mating surface. Also useful when you're doing boss. And I guess web is another big one. Geometric pattern. There's the lattice inside for 3D printing.
Wow.
There's a lot.
Amazing. Like when the plastic design extension first came out, and the level of automation in the way that it saves so much time for the user is really amazing to see. So yeah, thanks for taking us through it. And if you want to learn more, check the blog, check the self-paced learning. There's a whole series of videos on there. Really appreciate it, Kyle. And I guess with that said, and while we're talking about plastic injection molding parts, it would be remiss of us to not visit the simulation workspace. And we have the simulation expert, Mr. Jacob Weinstock, on the call. So Jacob, over to you, sir.
Thank you very much. Yeah, as Spencer said, I'm going to take you guys through some of the new improvements in the simulation workspace, in particular, the injection molding simulation. So I'm going to share my screen. Cool. So yeah, we've had injection molding simulation in Fusion for a little while now. So I've got one of my simulations I've set up before of one of the components from the same fan that Kyle was using. You can see here, this is just the first revision of the design. So things aren't looking great. There's some red areas here saying parts are unlikely to fill. If we go to the warpage tab here, some areas which have been highlighted, indicating you might have warpage. And like I said, this has been in Fusion for a while now, this simulation view. Some of the cool things you can do, just to give you a brief overview of this before I move on to the new stuff, is my favorite part of this is on the guided results option. It gives you some feedback, and it also allows you to click these blue links here and actually go back, and the links will be intelligently created depending on what errors Fusion has detected. So in this case, it's saying, to reduce the pressure drop, you might want to increase the overall thickness of the part. So you might want to do that. You might want to think about increasing the thickness of these webbed features coming out. So that's my favorite part about this workspace. You can also see some more in-depth results here. So we can see a nice fill animation. So I press play, we can see a fill time indicator on the right-hand side. And as the time goes along, the part's going to be filled up. So this is, like I said, this has been in Fusion for a while, but the new stuff I want to show you is the ability to create a report, which is new to the injection molding simulation workspace. So to do that, you can come up here to the top and click this report button. Click that, and then this window opens up. So you can quite in-depthly customize your report depending on what you're looking for. So just to give you some potential things you might want to change, you can attach a custom logo, which is on the report. So you might want to put your company's logo. For example, you can write a summary. So I can say first design revision simulation. That's some stuff you can do on the general tab. You can then come down to the report properties. So by default, we include the title and the author, but you can also add some other options that will appear on your report. So if you come down to the add option here, you can see a new row is being created. Then you can open this up, and we have some set categories which you can create. So for example, like I say, you might want to add your company. So for me, I can write Autodesk. You might want to add a revision number. So this is only the first revision of the part, so we can say 01. So these are the type of things you can create on the report properties tab. You can also add what we call project properties. So by default, we don't include any of these, but again, if you come down to the add button down here, you can create various properties. So for the sake of argument, let's choose project, and it's the desktop fan project. You can potentially add the designer. So, let's say I design this. And something as well, which is, I think the most useful options in this list are the approved by options. So most people in their companies, they have an approval process where a designer would design something, potentially a simulation engineer would run the simulation, and then someone to approve the final design before going to manufacture. So on here, we can do manufacturing approved by, and that might be your manager. So I'm going to put Spencer on this one. So you can see how you can build up a nice custom report depending on what properties you need. You can also open up the actual study settings. So by default, everything's included. If for whatever reason you don't need certain elements of this, you can just untick them, and yeah, they won't appear on the report. So once you've done this, you just press generate, and then it will create a window will open, and it will say if you want to save locally or save to your Fusion team. It's up to you which one you do. And once you've done that, you create a report. So I'm going to switch tab here and show you what the report looks like. So this is the report that's created from Fusion. And you can see here some of those properties which I added. So I made the title of the study, the fan body study, the author was myself, the company was Autodesk, some of those project properties I mentioned before, so the part number, potentially, the approver, things like that. And what's nice about this is it's actually an interactive document that's created. So on the left-hand side, you can see all those different elements of the report. So let's say you wanted to go down to the fill confidence section, you can just click that, and then the report will nicely jump to that section, which is pretty nice. You don't have to go searching through, because these reports can be quite long. You have a lot of info on here, so this makes it nice and easy to find what you're looking for. So yeah, that's it from me. I think the report option's been a long-standing feature, which has been available in FEA simulation, for example, but not quite made it to the injection molding simulation. And we have this now, so I think a lot of customers are going to be happy with this one. Back to you, Spencer.
Brilliant. Thanks, Jacob. It's really amazing to see the progress that we're making on that injection molding, especially for the plastics game. Couple of questions coming in. First one is, can you add custom properties to the report, or are we limited to what's in the list? Yeah,
unfortunately, right now it's only the set properties, but it's definitely, if it's a user request, we're all about trying to implement user requests, so we could definitely pass that on to the developers and they can have a look at implementing that. So it's definitely something we can look at.
Absolutely. And I guess what you could do is use one of the properties that you're not really utilizing, right? If you're not using maybe the comment or one of the other properties, you could use that for whatever purpose you want, right?
For sure, yeah. There is at the beginning, you had that large box of text that a large text box. So in theory, you could add custom kind of properties there if you wanted to. So it's kind of a workaround, but it is possible.
Amazing, great to see. I love the dynamic links as well in that guided help on the left hand side. It really, what takes you into the different workspaces, allows you to manipulate the setup of the injection molding process itself as well.
Yeah, especially if like you're quite new to injection molding. I know there's a lot of science that goes into the various design elements, and it's really good for beginners to help them achieve good quality results when it comes time to manufacture.
Great. And if people want to learn more, it's all about self-paced learning. It's all about YouTube, right?
Yeah, for sure. Yeah, check the blog, check the YouTube, check the self-paced learning. Yeah, it's all good stuff. Amazing.
Thank you, sir, for now. I really appreciate it. Thanks for taking us through everything in simulation. While we're on the topic of what's new, I guess, and without any further ado, I'll open it up to Mr. Kieran himself, who's going to take us through manufacturing.
Thank you very much. Thank you very much. Can you hear me okay?
Can indeed.
Excellent. So welcome, everyone. Great to be here. I'm going to talk to you a little bit about really kind of a whole bunch of new toolpaths, two in particular. This is only two of the many improvements and what's news that have come in the May release. I believe Spencer will post the link to that blog, so you can go and review what additionally has come into the manufacturing environment. But I'm going to talk to you about two specifically, which I think are the kind of biggest hard-hitting features for the May release. Okay, so it's no secret that Fusion's 4-axis technology is really quite woeful, and up until now has probably been minimal and in many ways non-existent. So what we're doing is we're introducing really a lot of technology as part of this May release to really help bolster our 4-axis machining capability. And we're doing this in the way of two new toolpaths. The first of these is what we are calling rotary pocket. Now, Fusion today, prior to this May release, only had really one dedicated 4-axis toolpath and the addition of the 2D wrap functionality within the 2D contour. Now, having these brand new two toolpaths really goes a long way to addressing our shortcomings in the 4-axis, simultaneous 4-axis game, but also really kind of brings us on par with a lot of our competitors. Now, this is the first of two new toolpaths, and they are dedicated solely to 4-axis machining. Now, this toolpath, both these toolpaths can typically be used on cylindrically feature-rich parts, and this will involve the three main orthogonal axes, the X, Y, and Z, plus an additional rotary axis, either the A axis or the B axis. Now, both these two toolpaths are simultaneous 4-axis capable, and it'll pretty much do a lot of what the 2D contour or 2D wrap functionality within the 2D contour will do for you today, but it'll do a hell of a lot more because it can be used on organic 4-axis shapes. Now, the slicing of this 4-axis toolpath can be used on both cylindrical as well as conical parts, in which case, if it is conical, it'll simply just kick that A or B axis over. The two toolpaths that I'm going to be talking to you today about, the first one really is really designed to be a roughing strategy, and with a bit of massaging of the toolpath strategy settings, you can make it a floor finishing strategy, but it is initially kind of conceived to be a roughing strategy. The second of those two toolpaths is going to be a wall finishing strategy only, and I'll talk to you all about that as we go in. So let's kind of walk into a scenario. And what you have today in Fusion is the only strategy you currently have to finish off a 4-axis style part. And that is what we call rotary parallel. Now, in the situations where the geometry of what you see on screen doesn't necessarily match the toolpath itself, then you have the kind of toolpath going up these vertical walls and kind of plunging down the other side. This is extremely bad for the tool, bad for the part, and ultimately bad cutting conditions all around. Now, it does this in a spiral fashion where it kind of wraps around and spirals around the part. But the rotary parallel strategy can also do radial machining. And when it does that, you end up with a similar result where it's still kind of plunging up and down these vertical walls, creating really bad cutting conditions. Now, if I kind of just turn on our leads and links, you can kind of achieve something with the 2D wrap functionality within the 2D contour. However, where the geometry wraps around more than 360 degrees, you often find that the toolpath breaks down, kind of fragments, and you have a toolpath which is effectively a non-starter. Really poor quality toolpath. Okay, so these are just some of the reasons why we've introduced these brand new two new toolpaths. Okay, so I'm going to just turn off our leads and links, and I'm just going to simulate the first of these two. And as I kind of jump into machine simulation, we kind of nudge the simulation over. The first of these toolpaths, as I mentioned before, is designed to be a roughing strategy. You can see how beautifully that the toolpath just wraps around the cylindrically feature-rich part, spirals around it, roughs it out, and when we finish roughing it out, we get to a point where we can, if I just kind of speed up the simulation, we then move on to the rotary contour strategy, which is specifically designed to be a wall finishing strategy. So the idea here is you use the rotary pocket to come out and rough those cylindrically feature-rich parts or conically feature-rich parts. And then you come in with that rotary contour style strategy to beautifully clean up those walls and end up with a beautiful surface finish. So that's some of the problems and highlighting how they're overcome by these two new toolpaths. However, let's dive into a kind of a little bit further into some of these toolpaths and look at some of the complexities as to what makes them quite a bit different to some of the other Fusion toolpaths. Now, when we kind of have a look at this rotary contour strategy, as I kind of rotate the part here, it's not just used for rotary or conical style strategies. It can also be used for rotary parts with pockets, not only pockets on one side, but pockets on both sides. Now, the beauty here that it has compared to some of the other strategies inside of Fusion is that it automatically picks up some of these pockets. And if you don't believe me that I've specified these pockets, I can go into the tab, look at geometry, and you'll see that there is no machining boundary specified whatsoever. So it analyzes the part, checks those walls, and then machines or puts that toolpath down on those vertical walls or steep regions or walls on our cylindrical feature-rich parts. The other thing to note is when we look at kind of this particular pocket over here, let's go in and have a look at the boundary that I've actually selected. Now, you can, as I say, use no boundaries, in which case it'll pick them all up. But you can also be more explicit and define certain boundaries. So in this case, what I've got is I've got a defined boundary on the one side, and then I've got a pair of nested boundaries or nested curves on the opposite side. Now, the bit that makes this toolpath different to other strategies is that typically with other Fusion strategies, we use a cookie cutter style approach when we've got boundaries, in which case, if you did have a set of toolpaths on the opposite side that you had a boundary on, you could often have the situation where you'd have toolpaths missing because that cookie cutter basically extrudes top and bottom and right the way through. But not so with these new rotary style strategies. What they do is they project to the rotational axis of the part or the center line of rotation. And so you don't have any situations where you're compromising any of the pockets on any of your cylindrical parts or conical parts that you're machining. So super efficient from that point of view. The next thing I want to point out, and I kept mentioning it a while ago, is the ability to machine conical feature-rich parts. Now, again, when we go and simulate this, and we kind of just move along here and we can kind of simulate this, you can see that the tool is actually kicked over on the A or the B axis or the B axis simply when we are machining conical parts. All we simply do is within the toolpath, you define your fixed tilt for cone machining. In this case, it's a -5 degree angle, in which case it just simply tips that tool over 5 degrees in either the A or the B axis. So you end up with a beautiful surface finish on that conical wall. So that's a benefit that some of the other technology we had just doesn't exist, but it does now. And then lastly, one of the really kind of important things I want to point out, and we'll kind of just simulate this with a machine to kind of show you what I'm talking about. And let's just kind of move this along a little bit, and we'll just kind of simulate as we're going along. And let's have a look from one of the sides. Now, one of the things you can see with this kind of spiraled toolpath is the first thing that's worth noting is that we're cutting with the center of the tool. We all know that cutting that there's zero rotational speed at the center of the tool and the maximum rotational speed at the extremities of the tool. So we want to be cutting with the outside of the tool, but also we want to be cutting with the leading edge of the tool. The fact that we're cutting here with the bottom of the tool just means you can end up with a very blunt surface finish, and we want to be cutting with that leading edge of the tool. Okay, so there's two problems as well. Now, we're not only cutting in a clockwise direction, as you saw there, it changes direction. We're also cutting in a counterclockwise direction. So how would we possibly deal with that? Well, the new rotary style strategies, they've got a pretty elegant solution to deal with this. Let's have a look at that now. And we're just going to kind of move that along a little bit. And as we kind of speed that up, and what you can see is now the tool is actually offset from that center line. And you can see that we're now cutting with the leading edge of the tool. Now, more importantly as well, as I just slow down the simulation, what you'll see is it's cutting with the leading edge, but as soon as it gets to the end of that rotation, we'll invoke a linear move the tool along in either X or Y, and then bring the tool back so that we're actually cutting with the leading edge on the counterclockwise portion of the tool. So this is super efficient. Just make sure that we're getting the best surface quality finish possible and that the toolpath is as most efficient as possible, but we're also saving our tool life by cutting on the cutting portion of the tool. And, you know, one of the things which we typically do at the Birmingham Technology Center is, you know, and I know it's very difficult to see with a blurred background, but this is a typical part that we've manufactured in-house. And this is the part that you're actually seeing on screen as well. I've programmed this, manufactured this part myself, so I understand the technology. And one of the things we do here at the Birmingham Technology Center is, in many ways, eat our own dog food, because we don't want you to smash your machines. We don't want your customers to smash machines. So we trial this out on our machines, prove the concept out, actually eat our own dog food by testing and manufacturing parts, so you don't have to do that. Trial and error to make sure all the technology you get is good to use straight out of the box. And I'd be happy to share some of these parts with you as well if this is something that you guys would be interested in. And that's it really from the manufacturing point of view for this month from the rotary aspect.
Thank you, sir. What delicious dog food as well.
Yeah, it is pretty good.
Where do people find a little bit more information about these toolpaths?
Yeah, so great question. The help documentation has got a whole host of extra documentation on these two new toolpaths. You can also find more information on the blog, which hopefully you, Spencer, will have posted in the chat. And then again, stay tuned on YouTube, because we have some of these videos, like, for example, the rotary pocket and rotary contour videos, tips and tricks of those particular toolpaths. We have that coming up in YouTube very shortly, so stay tuned for that.
That's amazing. And these all live and breathe in the machine extensions. That's
correct. So that's a very good point. So these are part of the machining extension. You do need to be a machining extension subscriber to be able to access this technology going forward. Very good point.
And for those that aren't familiar with the machining extension, tell us a little bit about that in the background there.
Yeah, so the machine extension got loads of capabilities, really, from all the way from whole part automation to multi-axis technology, from 4 and 5 axis simultaneous, all the way through to drilling and hole recognition and templates, all the way through to kind of probing, inspection, measuring your parts. So yeah, a whole host of technology that really kind of makes your life super easy and super easy to manufacture. Really gives you power, and in many ways, this machining extension has really kind of consumed a lot of the technology that we see from our specialist products, like, for example, Power Mill. So steep and shallow is a really good one. That's a whole part strategy that's come from Power Mill. So yeah, it's a really good way to kind of really leverage some of these automation and multi-axis technology and capabilities from within this machining extension.
Amazing. Thank you, sir. And as Kieran said, there's a whole host of new capabilities that we couldn't cover today in the short time span. So the links are in the chat if you're joining us on Zoom, and if you're joining us on YouTube, it's in the comments. Very quickly, just to close things off, a little look back at those key themes. Now, we mentioned these right at the beginning, and hopefully you saw some of those pop up as the experts are taking you through each and every workspace. So we started with that theme of automation, the idea that we want to start to streamline the user's workflow while they're using the product, and not just from a design perspective, but maybe cross workspace too. So render an API. And then under feature level, improvements to LIP, which Kyle took us through, improvements to parameters with conditional expressions, a whole host of automation tools to help you improve your productivity. We move over to a second theme of being comprehensive. And really, this aligns more with the manufacturing workspace than anywhere else. And it gives you two brand new toolpath strategies for four-axis machining, rotary pocket, rotary contour. But we've also got improvements to turning. We've got improvements to nesting for the 2D machining and additive. So I really do, if you're working in some of those other environments within manufacturing, go check the blog. There really is some amazing functionality. And then lastly, providing you, the user, with the flexibility you need to use the product the way you want to use it. So the big one there is snooze. Postpone that release for up to 14 days. Gives you the control to consume that update when you want to. Tokens for signal integrity extension, as well as opening up capabilities in editing place. So hopefully you saw some of those themes: automation, comprehensive control of the product, and providing you, the user, with the flexibility you need to use the product the way you want to use it. And I think with that, on behalf of me and all of the experts from Autodesk, thank you very much indeed for watching, and hand it back to the guys at KETIV.
Thank you so much. Incredibly informative. So many new things coming in Fusion 360 and available already in Fusion 360. So thank you, Spencer, Kieran, Jacob, Kyle, so much for your time today. Always great to get the updates, straight from you as the experts. This recording will be available on KETIV's YouTube page as well as KETIV.com. Please, stay engaged with KETIV Virtual Academy every Thursday at the same time. And with that, we will see you next week. Thank you so much for everything.
Thank you.
Thank you, everybody. Appreciate it.
Bye-bye.